Okay. And welcome back. Tracing and processing. Okay, today we going to continue talking about sensors. We're going to talk about more complexity of sensors in terms of the data that they provide. We're going to talk about that. We're going to see how we can categorize sensors based off the data that they provide. Simple sensors, the type of sensors that just give you beats or just a number. Moderate sensors, the kind of sensors that give you a vector of information like GPS or IMU encoders that need a little processing too. And complex sensors, that we're going to talk about that next class. Mostly we need some tools like neural network to process data because they give you a massive data that is not easy to process. You need some tools like neural network, for example. We're going to talk about that next class, but today we mostly going to focus in simple and moderate sensors. Our next class, we're going to see how these moderate and simple sensors can combine together. We're going to tell you how we can fuse them to still get do complex tasks. That's something interesting that we're going to talk next class. Let's get started. Before we dive into today's topic, let's quickly see what sensors we might need based off type of the robot. Most of the time we can divide the type of the robot to these categories in this table. Mobile robot, like Turtle bot that you have it in university. Drones, Turtle bot is like this most of the time. They have different version. They have lots of sensors. You can add more sensors to that. Like for example, this is LiDAR in top. This is LiDAR. They might have GPS, IMU. Probably they have IMU to measure, velocity or acceleration, those things. Encoders they have also encoders for wheels to see which direction wheels are moving, or even they can measure the distance that they are moving with counting wheels. They have some encoders to count, like with light or magnet. And ultrasonic or infrared, probably they have some here to measure distance to obstacle around. For drone, the same. For drone, probably you need even and camera too. I forgot to mention here camera. Of course, you can add camera. The delivery robots, for example, of course, they need to have camera. Like this is a delivery robot that in many European countries right now use for delivering packages, foods, as you can see here, there is a camera here. They need source of these sensors to find their position and be smart and to find the destination in the best way. Like localization is the main point of this kind of robots, mobile robots. We have industrial robots, the robot that use in industry, like factories, for example, assembly arms, mostly used for carrying heavy stuff, or the machine, CNC machine for cutting, metals or welding arms. When you want to make the body of cars, for example, they are coming and welding the pieces. They need for sure some encoders to measure the angle or whatever. They need torque sensors because they have some arms that they need to touch stuff. So they need to measure the pressure that they are putting to the things that they are carrying. For sure, they need some camera and probably more, but they are like the main things. We have humanoid robot, the robots that look like human, like now is a nice humanoid robot. It's designed in France, but right now the factory is in Japan, and Boston Dynamic, of course, is very famous. It's very nice robots that they do amazing things. They need camera for sure. They need whatever they want for interact with human, like touch, joint angle sensors. For sure, they need sound system. They need to speech or hear. They need microphone as well, for sure. Like a torque sensor, they need that too because they need to touch, and encoders, of course. We have autonomous vehicles like Tesla, Waymo. I didn't put the picture of that because everywhere you know that. Waymo is found by Google. It's very famous. Most of them they use lidar, radar. They use radar. They use GPS for sure. Anything that any type of robot that's supposed to work outside, most of the time they use GPS because GPS is good localization. Actually sensor for outside mostly. They need camera for sure. Like some of them, like Tesla, is very based on camera. And they call it Tesla Vision. They fuse so many cameras around the autonomous cars. And they don't use lidar, at least in this version that they have. And they think that enough camera eventually can be better than other sensors like expensive lidar. Radar and lidar are very acting similar. So some use like frequency signals, some use light to get distance. However, processing from radar to lidar is very complex. So lidar by itself not give you enough information. It is very, complex to get meaning out of radar. So you need a neural network to transfer the output of radar to lidar. I think radar is cheaper in terms of price compared to lidar, but it needs lots of software. Most of these sensors need lots of softwares to process them, to fuse them, to get meaning out of them. And ultrasonic for they all have it. All of maybe most of autonomous vehicles are using ultrasonic sensor like IR to detect how far they are with the other cars. And most of their system rely on that. Like, for example, to adjust the speed, like compared to the other cars in front of them, they need to use ultrasonic to get distance to that car and adjust their speed based on that. We have service robots like vacuum cleaners or elderly care robots that these robots need for sure some bump sensors. If they hit something, they need to come back and they don't need to go more, they need to stop. Or IR to get distance, and microphones to communicate with their customers or the people around. Like they are for elderly, they need to talk to people. And they need to be funny too. And the things that is very important, interesting, is swarm robots, the robots that collaborate to each other. That's a very open topic right now, when robots need to help each other, collaborating robots, and like multi-drone systems, when we have lots of drones that doing something together. Probably you saw so many videos, they are making something with movement. They can create pictures or 3D things, or ant-like bots. Ant-like bots are very simple robots. Here you can see the picture. They are helping each other to move like objects. That's very interesting how they can do that. That's called collaborative agents. So they are helping each other in a very collaborative way to do a task in an optimal way. So optimization is not like normal optimization, it's like a distributed way. And that's very hard and very open topic for research right now. We have so many different agents that can help. Even if they can be like a mobile robot, they help each other to do something. Like, for example, firefighters, robot that doing like act as a firefighter, they can help each other to optimize something together. You know, the general utility is important right now. It's not personal, it's together. They need to do general optimization. It's very complex because they are related to each other. And dependency is very complex to implement in computer. We have underwater robots. Underwater robots are also so many applications these days, like AUVs, autonomous underwater vehicles. These vehicles, I have the picture. Mostly, they need to autonomously. They go underwater. They do like serialize something. For research they can use for so many applications, or sometimes they call ROV, remotely operated vehicles. And that because they are in a certain environment, they are underwater, some sensors not working, GPS not working, for example. They can rely on sound because sound is very good transferring underwater. They can use anything related to sound, like sonar is like that. Sonar is like a sound navigation and ranging system. Sonar can actually get information about surrounding using sonar, or they need some pressure sensors to probably understand which depth they are based off the pressure, or that's something that they need. And they also rely on sensors that mostly they call Doppler sensors, or Doppler velocity log. Doppler method can be used for measuring your speed compared to the speed of other obstacles or other objects. Underwater is working very nice because it's mostly based off sound and can be measured. They have camera too. However, camera still is not very good underwater, but they need camera for, you know, if they want to check marines or something, or search something, they can use that. This is very open subjects, underwater vehicles. And underwater, so many things happening. It's not easy things. So many that you, things happening because they are not like controllable that much. The water has currents, and obstacles are not visible. Sometimes coming so fast, like for example, fish or other things. And the space robots are also type of the robot that they need a specific type of sensors, for example, Mars rover or satellite arms that for sure, because they are armed, if they have arms, they need them like encoders, they have like a torque sensors, of course they need camera, and if is like a Mars rover, because it's also mobile robot, they need some sensors from robots, mobile robots like IMU, LIDAR, and because they are in, you know, out of Earth, so they need radiation sensors to measure that as well, and those sensors need to be also able to work in that area as well. You know, that's also important. Like computers are very sensitive to radiations because it's just a bit. It can change 0 to 1, you know, easily. So the designing the hardware is so is different than normal design. If you want to work in like satellites, in you know, other, you know, in moon or anywhere else, Mars. Okay, so this was just something that I wanted to let you know before going to. Oh, this is the Mars rover, and this is the arm, satellite arm. Okay, so let's go see how we can categorize sensors based off data complexity. So based off data complexity, we can categorize sensors to simple sensors. Simple sensors normally they have very low bandwidth in terms of data that they provide, like 0 and 1, like for touch sensors, for example, or just a number, like for temperature. And they don't need that much processing, not that much processing, minimal processing, like touch, for example. Infrared, it can be considered just a number, give you distance. Temperature can give you again a number, and switch can be 0 or 1. Moderate sensors, they give you a structured data. A structured data is like a vector of information for localization. For example, position, velocity, acceleration, jerk. This information about the motion are structured, and they are very important for robots to act based off these moderate sensors. Like for example, IMU, GPS, encoders are this kind of sensor. Most of mobile robots, they need these moderate sensors, and these moderate sensors need to combine together. By them, just one of them is not enough. Most of the time we use a couple of them to fill the gap if something happened In some areas, they need to help each other to update. Because localization mostly coming from measurements and update. The update is important part of localization. When you get measurements, you need to update it every time, and this process need rely on fusing this information. So we need some of them to correct each other. We're going to see application next class. I have some example to see how they can complete each other. And complex sensors, for sure, the complex sensors mostly give you like a rich data, lots of data that even is hard to understand. If you look at them, they are not really understandable. You need to have techniques like machine learning or AI, or the way that we learned last weeks about neural network or deep neural network or convolutional neural network. Those techniques can be used for understanding or getting meaning out of those sensors, especially LIDAR or radar. Radar and LIDAR are similar mostly. And cameras as well. Camera give you lots of information, but this information need to recognize, classify, or get meaning out of that. It's just the picture is just 2D dimension or maybe 3D dimension. To get meaning out of that, to take out the object, to understand what they are doing, we need lots of process that happen with the techniques that we learn. Most of them, we learn most of them. We can learn more in following weeks. I will talk about some of the methods or techniques in addition to what we learned before. Like for example, I'm going to talk about Kalman filter. That's something that not very deep. We're not going to go deep. We're just going to see application of Kalman filter, and just one project. We can do that to just see how Kalman filter can help to fuse information, to deal with uncertainty and noise and those kind of things. So this is what we want to talk. Let's go for simple sensors. First, touch. Touch is a very simple sensors, mostly in robots, humanoid robot, or any arm that need to touch object, carry object. We use touch sensor. Touch sensor is very simple because it's just make 0 and 1. Just the bit information. This bit information, if they hit something, they if they contact something, they open the circuit or close the circuit. That's very simple how they work. So because it's just a bit of information, we consider them as a simple actually sensors. Okay, so that's something that if the robot is carrying something, we need to deal with that. Another one is IR, infrared, sometimes proximity sensor, that give you the distance to surrounding. And they are active sensors because they emit infrared and they measure reflected light. They emit infrared, and like for example, if it is the infrared, they send it and they receive the reflected light, and based off comparing time and the speed of light and so many other things, they compute how far obstacles are, if there is obstacle. Like for example, there is an obstacle here, so they can measure that distance. Like with centimeters, some of them are not so precise, some of them are very precise, and even there is a meter, like you can use it, measuring meter with this technology, IR technology. You just can send a laser to some, and it's going to give you exact distance, very precise, that used in construction and so many applications. The LIDAR is also working based off IR. They use this technology. They emit infrared, and they have different type of actually laser that they can use. But anyway, the technology is the same. That's why I had a project a couple of 2 years ago. Actually, one of the students did with using multiple actually IR. He wanted to create a LIDAR sensors to turn that, get a 3D dimension. It's very complicated, but it's possible. It's possible to get a 3D dimension using multiple IR that is turning. However, you need software to adjust this sending and receiving and computing the 3D view of the environment. This is something that is possible. I think so many applications exist. If you check in the internet, you can find some application of that, how you can use multiple. This is what I want to say. Sometimes using multiple of these sensors can give you amazing power. Instead of having one, you can have like 100, for example. IR is a good one, because it gives you distance if you have multiple of them, and have a arrangement to turn them or whatever, even not turn them, just cover them all around the robot. You can get so many meaning out of that. So that's an infrared or proximity sensor. Most of the robot right now, they have IR because it's very cheap and is easy to process. It's considered like a simple sensors, because just give you a number. So yeah, is actually show you the distance, how it works. So LED emit light, and they wait to get actually reflection and compute time most of the time, and this is how they work. Temperature sensors, we use them in robots, sometimes to measure the temperature of outside, sometimes to measure temperature of inside the robot. If the robot is in a, for example, industry or working in an area, you also need to take care of robot, inside of robot. If it's too hot or too cold, it should be actually not good for the equipment inside the robot or the processor or whatever. As I mentioned, even electrical or electronic systems are designed for a certain temperature. If it's not in that temperature, they are not working fine. So we need to always actually take care of that area. We can use this kind of sensors all the time. These sensors just give you very simple information that is like a degree. It can be centigrade or Fahrenheit. Very low data complexity. You can directly use it. They use like thermostat or digital ICs to detect temperature. And as I mentioned, it can be used for inside or outside. We have switch sensors. We talked last class as well about that. This switch sensor, like a bumper, that if robot hits somewhere, we want to stop it, because probably you saw sometime the robot going to hit the wall and it just continue hitting and hitting. So in this case, you need to understand that's the ultimate way to stop it and make another action. If this happen, Yeah, so most of the robot need something like that. Or sometimes you need to robot to just stop. You want to, it's like a security key. So you want make it stop to don't continue. That's another thing that we need to consider most of the time in terms of security things. But this is the time that still we are controlling the robot. We are designing the robot. Imagine a couple of years from now, the robot gonna make robot. And if we go in that time, when the robots or smart agent design another agent, they might not do those things because so why? We want to get, we want to be free. That's amazing to think about that. That's the ethic behind robotics or AI, and we need to consider that. Okay, so having a switch for on and off the robot right now, at least, is something that we need to consider. What else? Output is just true and false or 0 and 1. It's not very complicated. It's easy to process. It's just a bit. Let's go for moderate sensors. Moderate sensors are more structured. We use them a lot. Most of robots that they have motion, they use this kind of robots, the sensors. They use it for localization, to get their position, motion tracking. And most of the time, these sensors combine with other sensors or with simple sensors or with each other. The one of important one is inertial measurement unit that is based off inercy, is working based off inercy. It means if something's not, anything that's changed its position to motion, it makes inercy. And this measuring this inercy, these sensors can measure these inercies, like anything that's moving. So inertial measurements unit sensors mostly give us 3 types of information. They give you acceleration. They give you gyroscope information. And sometimes they have, magnetometers. So normally they have this kind of information. We're gonna see them more soon. Next slide. So normally IMU sensors used when you have motion in your robot, the robot moving. GPS is also another sensor that we talked about that before. Its limitation, there is lots of limitation, but mostly outside when you need to know the position, you can use GPS. GPS working based off the satellite-based system, so that's another limitation. If something happened in the satellite, they might not work fine. Normally, they give you information about the position, latitude, longitude, and sometimes altitude if it's flying, for example, flying robot, like a drones, and even can give you a speed and heading. However, that's not come directly. That need to process with the software to give you a speed of the object and heading. We can see that. And we have encoders, or wheel encoders, or sometimes called shaft encoders. They are the kind of sensors that contain the wheels movements to measure the direction of motion and also how much is moving based off the turning the wheels. They can count that. They use different ways to do that. So these kind of sensors called moderate sensors. We're going to see them and talk about them more. And why they are important? Because they are fundamental for localization and odometry. In so many applications, we use them. Like when we have localization, simultaneous localization and mapping SLAM. This is something that most of autonomous robots need to have that. They sometimes they go to that new area. They need to localize themselves and also make a map. This is simultaneously. They are at the same time. When they are dealing with the unknown environment, they need to localize themselves and also actually make a map of the environment, like what we are doing. What we are doing when we are, for example, going to a new place, we just watch everywhere and we try to memorize. And when we walk around and when we see that again, we correct everything before, you know. Imagine you are turning in this level and see the rooms, and you turn and come back here. And when you come back here, you make a loop and you correct your errors. Because before that, you didn't know where you are going. And when you are coming, you say, oh, you make a map. And that's something that SLAM working based off that, making these loops is amazing, amazing algorithms. And it's mostly work based off probability and actually Bayes formula. We call them Bayesian optimization. They use that to localize and at the same time make a map of environment. So let's go deeper in IMU. Inertial measurements unit. So they mostly give you, they have accelerometer inside to measure linear acceleration. They can give you acceleration in X, Y, and Z. And they have gyroscope to give you the angular velocity, omega X, omega Y, and omega Z, if there is a 3D. And they also give you, not all of them, they all have some information. Any type of IMU, they have a data sheet that give you what information they give you. They have magnetometers to measure magnetic field for heading estimation. So normally they give you a vector of information or a matrix of information. So that's why we call them structured, because give you this information. AX is acceleration, angular velocity, and magnetometers or magnetic field heading estimation. So this is good to know when you have a robot that's moving. We have global positioning system, GPS, that we talked about that before. So normally this sensor give you global position. For example, if you have a robot right now here in Houghton, it's gonna be, for example, the latitude is 47 degrees, 7 minutes and 16 seconds. And I make it like 2 line. And actually that's latitude. And longitude, or it has west, or this is north. And longitude is 88 degrees, 24 minutes and 9 seconds. So it means the second and minutes showing that, for example, each degree, if you divide it by 60, it's like a clock. We are considered act like a clock. And if again divided by 60, it's gonna go to second. So we divide it by degrees and seconds. the degrees, minutes, and seconds. So this is V. So this is the position of Houghton. This area is like this degrees. It's very important when you, and even changing this or finding exact position that is important. It needs lots of calculation. Actually, I was working in a project and they were making surface robot, the robot that's moving in an ocean. And we were dealing with this a lot. And in that area, we had the motion, in water was moving a lot. And we should find a path that actually find the best way or time to pass the water, because the ocean water most of the time is based off the time. Like for example, in some hours of day moving, for example, in one direction and the other. Even this canal, I realized that this water has motion too. I can define some project. There is somebody to fund it regarding to that, to how, for example, we make an autonomous boat to move in this area based off the optimizing the motion, the water's motion. Anyway, that's how GPS works. So GPS is important when we have robot that working outside. As I said, because the GPS working based off satellites, at least you need 3 or 4 satellites to get proper position. Based off these satellites, even you can compute, or the software can compute the speed and also heading, which direction moving. And why it's matter, only sensors that give absolute global position. That's the only sensor that give you absolute global position. And for outdoor navigation is necessary. Also for SLAM or anything related to geo, you need to use that. Okay, that's a global position. Encoders. Encoders also are very useful. They mostly work based off counting motion of the wheels. So as you can see in that picture, like here, for example, this is based off the light. They are passing light. When the wheels turning, they can understand which direction wheels moving, and they count it to see how much they are moving. So some of them working based off optical encoder. They count the light. They have a counter, like digital counter, they count the light. And some of them working based off like a magnetic encoder. They use magnetic sensors to do that. Anyway, they give you some information regarding to actually, they give you the tick count. They call it tick count. They're showing how much is moving. However, based off the size of the wheel, need calculation. And also direction, if they move like a forward or backward. There's different type. Most of robots that's moving, they use this sensor as well. Like that turtle bot robot that you have it here, they use that. Okay, so we finished it early today. So yes,